Hello everyone, this is Dr.G.Karthik Reddy, Associate Professor, Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. The topic is types of events in probability. And this is an overview of the contents. Okay, in this, today we are going to discuss introduction, types of events in probability, mutual exclusive and exhaustive events, discussion on individual event with an example. What is the definition of probability of occurrence of any event? Number of favorable outcomes to the total number of possible outcomes is defined as probability of occurrence of any event. Okay, event can be anything. Tossing a coin. Okay, in that favorable is one of the experiment. Probability that an event will occur is definition is P of E. Probability of an event is equal to number of favorable outcomes by total number of possible outcomes. And here each and every event is a subset of sample space. This one we are going to discuss with an example. For example, okay, we are doing some random experiment. Two coins are tossed simultaneously. When two coins are tossed simultaneously, we are having four possible outcomes. The possible outcome is called sample space. What are the four possible outcomes? It may be both the coins showing same head, or one head, one tail. First coin is tail, second coin is head, and last case, two coins are tail. Next, this one we are representing in pictorial form, that is called Venn diagram. Venn diagram is a pictorial representation of the logical form of the sets. For example, here I am considering H combination of head as lambda 1 and head tail as lambda 2, tail head as lambda 3, and next tail as lambda 4. And here each and every lambdas represents sample point. Then this is the one of the event, and this is the one of the event, and this is the one of them. For example, what is the event here? Okay, when you are tossing two coins are simultaneously, what is it is showing? The probability of showing head is lambda 1. Okay, probability of showing tail is lambda 4. Probability of showing any one as head, then it is showing as lambda 2 and lambda 3. Okay, the pictorial form representation, all the possible outcomes is called sample space. Okay, sample space, you are having four possible outcomes. Okay. Now next we are taking with one more example. Okay, Okay, here for example I am considering A. A is the okay, for example, I am doing an experiment, throwing a dice. Okay, what are all the possible outcomes for throwing a dice? All the possible outcomes, S is equal to 1, 2, 3, 4, 5 and 6. Okay, these are the possible outcomes for throwing a die. Next, for example, I am considering let A be the prime. Okay, for example, I am considering when you are throwing a die, I required only the prime faces. What are the prime faces? 2, 3, 5. Now second, B I am considering as I required only even faces. What are the even faces? 2, 4, 6. Next, third one, I required only the odd faces. If I required only the odd faces, what are that? 1, 3, 5. 1, 3, 5. If you write this, okay, A is one event, B is another event, C is another event. And you can also observe from this, okay, just all these numbers I am representing in the here 2, 3, 5. Okay, here 2, 4, 6. Here you are having 1, 3, 5. Okay, all are interconnecting to each other. And just I am representing this like this. Okay, representing like this. You are having A. You are having, for example, 5. Okay, 2, 3 is a common term. You are having 2 here. Next, here you are having 3. Okay. Next, here you are having 4 and 6. Here you are having 1 and 5. Okay, these are all the possible outcomes. And next, the probability of getting an event A. Probability of getting an event A is from 0 less than or equal to P of A less than or equal to 1. Okay. Next, probability of getting an event B is also, it lies between 0 and 1. Next, probability of getting an event C is also, you are getting in between the value 0 and 1. And probability of getting, okay, all the possible outcomes, okay, all the possible outcomes, that is a is called sample space. The probability of sample space is 1. The probability of sample space is 1. And you can also observe that, okay, event A is part of sample space. That's why we can also call as event A is the subset of sample space. Similarly, event B is a subset of sample space. Similarly, event C is a subset of sample space. Okay. Now, next, types of events. What are the types of events in probability? We are having the different types of events. One is impossible and sure event, and second one is simple event. Next, third one is compound event, and fourth one is independent and dependent event, and fifth one is mutually exclusive event, and sixth one is exhaustive events. These are the 6 different types of events in probability. Next, okay, first, before discussing that, we will have some more examples, like when a die is rolled. When a die is rolled, you are having the total number of possible outcomes 1 to 6. If you are considering first event I am considering as event phases, you are getting 2, 4, 6. 2, 4, 6. And second is a prime event 2, 3, 5. 2, 3, 5. And the intersection portion is called, intersection portion which is between event 1 and event 2 is 2. This is the intersection portion. Now we will discuss the some types of first type of the event, that is impossible and sure event. What is impossible event? Okay, if the probability of occurrence of event is 0, probability of occurrence of event is 0, then it is called as impossible event. Next, the probability of occurrence of event is 1, then it is called as sure event. Okay, then it is called as sure event. Like probability of occurrence of, for example, you can take sun rises in the east. Okay, and sun rises always in the east. That is why the probability of occurrence of that particular event is always 1. Okay, sun rises in the west. No, it is impossible event. That is why the probability of occurrence of an event is 0. Means, so therefore we can conclude that the probability of a particular event lies between 0 and 1. In between 0 and 1, the probability of a particular event lies. You can also take from the set theory that empty set is called as impossible event and the sample space is called the sure event. Okay, in the sample space you will get all the possible outcomes. All the possible outcomes you will get in the sample space. That is why the probability of that sample space is always 1. You should remember that probability of sample space is always 1. And probability of empty set in the set theory, you are calling that as impossible event, that is always 0. Next, we will discuss the next type. Next, simple and compound event. Okay, any event consisting of a single point. Just now I discussed the single point. Okay, single point of a sample space is known as simple event of the probability. Okay, you can consider the example S is equal to 56, 78, 96, 54, 18. You can take any one point, that is called simple event. Okay, when you are taking the any event consists of more than one single point is called compound event. You can take the example, that same example I have taken with combination of 2 or more, that is called as compound event. Next, this is one of the important one. Next, that is mutually exclusive and exhaustive event. Okay, first we'll discuss about mutually exclusive. If the occurrence of one event excludes the occurrence of another event, such a event is called mutually exclusive event. Mutually exclusive. In general terminology, we can also tell that two events does not have any common point. Two events does not have any common. We'll discuss with an example. For example, when you roll a die, you are getting 6 possibilities, 1 to 6. Okay, you are considering two events, event 1 and event 2. Okay, event 1 tells that it consists of numbers less than 3. And next, event 2 consists of numbers greater than 4. Okay, both are not having any overlapping term, and both, therefore, okay, event 1 having the possibilities 1, 2 and event 2 having the possibilities 5, 6. Therefore, they are not having any overlapping between the two events. Therefore, these two events are called mutually exclusive events. And set of events is called exhaustive. Next type. If all the events together consume the entire sample space. For example, if you are taking the first event 1 having the numbers up to 3, up to less than or equal to 3, then you are having 1, 2, 3. Next, event 2 having the all possibilities greater than or equal to 4, that is 4, 5, 6. By using these two events, cover all the outcomes of a sample space. Therefore, this is called as exhaustive event. We will tell with one more example also, clearly by using pictorial representation. You can observe in this figure, in the left side, you are having 4 events, event 1, event 2, event 3, event 4. All the events which are not overlapping to each other. Okay, event 1, 2, 3, 4, and they are having some empty space between the events. Okay, and the total sample space, all the possible outcomes is 1. Next, we can also write this each event having the range between 0 to 1. Okay, same condition I have written, and E of I means I equal to 1, 2, 3, 4. Here you are having 4 possibilities. Next, what else you are having? Okay, you can also write this as probability of event 1 plus event 2 plus event 3 and event 4. If you combine all the values also, it will be less than 1, because you are having some empty space which is happening in this sample space. Okay, same example I am taking with, okay, exhaustive. Okay, exhaustive. Here event 1, event 2, event 3, event 4. It is covering complete sample space. Here also probability of sample space is 1, and here when you combine all the events, it must be less than or equal to 1. It is less than or equal to 1. And here you are having less than, okay, you are having smaller value compared to this exhaustive one, because in exhaustive it is covering complete sample space. Next, I am going to discuss next type, independent and dependent events. If the probability, okay, if the occurrence of any event is completely unaffected by the occurrence of another event, such events are called independent events. In probability, and events which are affected by another events are called dependent events. Okay, which is antonym to this. For example, if you flip a coin once, then we get the outcome as head. If you flip the coin again, this time you will get the outcome as tail. In both the cases, the occurrence of both the events is independent to each other, because when you flip a coin first time, okay, you are getting the outcome as head. Next, when you flip the coin second time, okay, we are getting the outcome as tail. But here one is not affecting the another occurrence of, means here occurrence of the event of the head in the first chance and occurrence of event as tail in the second chance, both are not affecting by the occurrence of another event. Okay, this is the best example of independent events. Okay, independent events. Thank you.